So welcome. Today we will discuss another combination circuit that is known as multiplexer. So we will discuss the multiplexer. Multiplexer is a combinational circuit which is known as many to one. So the tagline or punchline for multiplexer is many to one. Means we have n inputs and output. How many outputs? These must be 1, so only one output and n inputs. So if we will look at it, the truth table, so n inputs and one output. But if we want to select one input to the output, then we have to select those. So it has basically two select lines, s1 and s2, and output is only 1. So this is the truth table for multiplexer. When both input are 0, then we will get at the output I1. When 0 1, we will get another input to the output I2. If 1 0, then we will get the third, and 1 1, then we will get the fourth one. So we have two select line and 4 input line and 1 output. So the connection between the input and the output, if we have 2 to the power n input, then we will require n selection lines. So suppose if we have 2 to the power n inputs, then how many selection lines will be required? Selection lines, and these will be n selection lines. So this is the relationship between the input as well as the selection line. Suppose we will put n is equals to 2, then how many inputs are there? Input will be 4, and how many selection lines? Selection lines will be 2. So we will draw that circuit. So we have two selection lines, so first we will draw those. So and the important thing is that it is the extension of the decoder circuit. So first we will draw the decoder circuit, because in the decoder circuit we are also doing the same thing, so there is no need to confuse with decoder and multiplexer. Again we have to draw the decoder circuit. So it has 4 outputs, these are okay, but decoder has 4 output, but multiplexer has only a single output. So these all 4 output are going to be input as a OR gate. So this is the output by. Now this is the decoder circuit, and we have two selection lines, S1 and S2. So what we are doing? Again we are negated inputs providing to the inputs. So this is first when 0 0, and the third input must be there, that is I1. Then we have to provide the 0 1. So S1 value must be 0, so we will provide from here. Then S2, we will provide S2 from here, because S2 will be 1, and the third input, that is I2. Then we have to provide 1 0, so S we are taking from here, then S2 we are going to take it from here, and the I3, this is the third input. Then S1, then S2 and I4. So this is the complete multiplexer circuit. You can see this is the decoder circuit, and what we are doing with the decoder circuit, we are putting all input to the one OR gate, and we have four inputs. That is the only difference between the multiplexer and decoder. So we can say mux is a circuit which decoder circuit plus OR gate for and inputs. So this is multiplexer circuit where we are putting four input and one output, and which input is going to connect to the output, and that is decided by the selection lines. So this is the difference between, and this is the addition to the decoder. So it is some extended circuit of the decoder when we will put the input as well as the OR gate, and it becomes the multiplexer. So this is the multiplexer circuit, and it is a combination circuit again. Thank you.